Okay, here's warm-up number 8.3. Are the two triangles similar? So since I'm only dealing with angles here, I'm thinking angle. My angle similarity postulate. So I need two pairs of congruent angles. I've got one right off the bat, those two 88-degree angles, but I'd want to find another one if I can. So what I'm going to do is find the missing angles. So I'm going to find this angle over here. So I'll just call that x so I can write an equation. All three of these angles are going to add up to 180. Okay, I'll combine those to 150. Okay, so this angle is 30 degrees, so that was close, but I didn't have a match here. So let's check this other missing angle just to make sure. I'll call this y. Combine my like terms there. And subtract 116. So this is 64 degrees, so I only have one pair of matching angles, and that means that, no, I just don't have enough for AA similarity. And my explanation is just showing that I only have one pair of congruent angles, okay? In the next problem, I've got two triangles. I've got the little triangle here, and I've got the whole big triangle, right? So I've got these two triangles that overlap, so I know that that's true. I'm going to draw these triangles separately. So here's my little one. And then the big one, it's still going to be a little smaller than the real big triangle is, but that's supposed to represent the big triangle. So I've got that one pair already, okay? Now it's tempting to think of these as corresponding angles, and they are corresponding angles, but I don't have that the lines are parallel yet. I could actually show that they're parallel by the converse of corresponding angles, then find these two angles congruent. But a little quicker way here, I think, is to use the fact that angle D is at the top of both triangles. So I can use the reflexive property of congruence to get angle D's congruent to itself. So my answer here then is going to be yes, I'm going to use reflexive property of congruence, and then the AA triangle similarity postulate. Okay. Next problem. So looking for two angles again. So most people will go for those vertical angles, and that'll work for sure. I also have the parallel lines at the top and bottom, and if you think of those as your tracks, and then you choose one of the transversals, it doesn't really matter which one. If I choose this one, then these are going to be congruent because they're alternate interior angles. And if I use the other transversal, or I could actually use the third angle theorem at this point, but if I'm using this, then I can do alternate interiors again to show that these two angles are congruent. So I've got more than I need here. I actually have three sets of congruent angles, and I only need two. So my answer is going to be yes. So I use vertical angles, although you could do this without the vertical angles if you just did the pink and the green angles there. But I used vertical angles theorem. You're definitely going to have to use alternate interior angles theorem at some point. And then we have enough, again, for AA similarity postulate. Okay. All right. Last problem. Zartan is 6 feet tall and casts a 4-foot shadow. A nearby building casts a 38-foot shadow. How tall is the building? There's no picture here, so I'm going to draw my own picture to organize the info. So there's the ground. So let's see. We have a building in here. So here's my building, and then Zartan is a person. So there's my person. There's Zartan. Okay, so let's see. Zartan is 6 feet tall. Okay, casts a 4-foot shadow. So if I draw a little triangle coming off of Zartan like that, a lot of times I see people put the 4-foot shadow, put the 4 right here. That's actually incorrect. So if you're looking at a shadow, you don't see a line in the air like that, right? You would measure the shadow on the ground. You'd see the shadow on the ground, so the 4 would go there. If you put the 4 here and you put the other number in the kind of a similar place on the building, you'll get the right answer on this one, but should really be there, okay? And then for my building, I'm looking for the height of the building, and it casts a 38-foot shadow. Again, you measure that 38 feet on the ground. So I've got these two triangles now, and these triangles are going to wind up being similar triangles. So let's think about why. So the sun would be, I don't know, somewhere up here, okay? And so that means that these two angles, the angle that the sun is coming, casting the shadow, is going to be the same. I mean, yeah, it's going to be a very, very small difference, but it'll be insignificant. So those two are the same. Also, the angles made with the ground would be the same. And if the ground is flat and the building and the person are standing straight up, then you got right angles as well. But anyways, these are similar triangles. And now I can set up a proportion. X is going to be to 6. These are matching pieces, as 38 is to 4. Those are matching pieces. So I can set up a proportion. Okay, you could cross multiply right now if you like, just like that. I like to always reduce the fractions just to get smaller numbers so I can see those are both even numbers. Let's divide them both by 2 then. So I'm going to get 19 over 2 for that second fraction. Just got myself some slightly smaller numbers to deal with. And now I can cross multiply. So 2x is going to equal 6 times 19. 6 times 19 comes out to 114. And then dividing by 2. All right, and that's going to come out to 57. And any word problem, you want units, right? The building is, when I need to say if it's 57 inches or centimeters or miles or meters, this time it's feet. All the other measurements are in feet. So 57 feet is my answer, okay? That's the end of the warm-up, and I'll see you next time.